Good morning, ladies and gentlemen. Thank you for signing up to the Geothermal Lithium and Sustainable Battery Production in the EU webinar. We're just going to wait another few minutes for other people to log in, and then we will start off our presentation. And for those of you who are familiar with, as we all are with webinars, you have a question function. So if you have any questions that you would like to ask any one of the panelists, or a broad question to the entire panel, please do write your questions and we'll bring them up either after a speaker has made their intervention, or when we have a general question and answer session. We'll just wait a few more minutes. It's like watching the election results come in the US. The numbers are just getting bigger and bigger every time we look. So it's still exciting. And okay, I think we're nearly there. Okay, well, I think I will make a start now. So again, once again, thank you very much for joining this webinar on sustainable battery production in the EU with geothermal lithium, hosted by EGEC, the European Geothermal Council, and kindly promoted by Recharge, who will present themselves very shortly. You can see from our agenda, I will give a brief introduction to geothermal for those who are new to geothermal energy, the quickest insight you'll ever get to one of the most exciting renewable energy solutions in operation. We'll then be followed by Miss Pia Elena Langer, who's the head of internal and external communications at Recharge Batteries Europe. We will then be followed by Dr. Horst Kreiter, who's the co-founder and executive director of Vulcan Energy Resources Limited, and he will give us an insight into geothermal lithium. Dr. Robert Pell, who's the founder and director of Miniviro Limited. Apologies if I've mispronounced that, but Robert, you'll have a chance to correct my error. Who will talk us through sustainability in lithium production. We also have Mr. James Firth, who's the head of energy storage at Bloomberg New Energy Finance, who will give us a broader snapshot of the lithium-ion market and the developments, opportunities, and challenges for the EU. And finally, Ms. Claudia Hamon, who's a member of the European Parliament for the Renew Europe group, will give us an insight into the debate that's going to happen within the European Parliament and the key criteria and the importance of sustainability throughout. And of course, we'll have a question and answer session at the end. But as I've mentioned, if you have a specific question to a speaker as they speak, please do write it in the question box, and then we'll be able to move forward and raise the question either at the end of the presentation or in the general Q&A at the end. Okay, so without further ado, let me briefly introduce you to the wonderful world of geothermal energy. So you will see that a geothermal is many things to many solutions. It's an endless source of renewable heat, which is stored below the surface of the earth. And as the deeper we dive, the different opportunities become available to us. We produce heat, that's renewable heat, it's constant, supplies every single day of the year, every single minute that's available as well. That can be used for heating in terms of heat pumps, which are used in buildings, such as the European Parliament, which starts drilling for geothermal this week. So look out for the fantastic opportunities if you happen to be within the area to see it happening in real life. Other parliaments like the Bundestag in Germany, the Maltese Parliament. We have, if you wander around Brussels, you'll see the NATO headquarters also has heating and cooling provided by geothermal energy, as do many installations have electricity produced by geothermal. And the most important thing about the electricity production is again, because geothermal is an endless resource, you have baseload electricity. So it's a very exciting opportunity there. And we have a very outdated map showing some of the mapped reserves within. Oh, sorry, I can't think of this season there. Within Europe, and this is constantly expanding as we get more and more geological data coming in. So more information about geothermal, we will be happy to provide you afterwards. But for the time being, let's move on to our first presenter, who is Miss Pia Alina Langer, who's the head of internal and external communications at Recharge Batteries. Pia, over to you. And I will just make you the presenter now. Yeah.
Yes, thank you very much, Sanchef. Can everybody see that?
Yes.
Yes, audio is good too.
Perfect.
Okay, wonderful. So thank you, Sanchef, for the kind introduction and for inviting us today to contribute with some key facts and figures about the European battery industry. Really just some words about who we are, who Recharge is. Recharge is the decisive industry voice for the advanced rechargeable and lithium battery value chain in Europe. And what do? Well, we do promote batteries that are environmentally friendly, safe, and socially responsibly sourced, manufactured, and also treated at the end of life. And it is in this capacity that we are interested, obviously, in how geothermal lithium, for example, can potentially contribute to the further development of the European battery ecosystem. Now, Recharge represents the entire value chain, right? From raw materials extraction to battery cell and pack manufacturing, to the OEMs, throughout to the recycling and transport organizations. And I think this puts us in a very good position to speak with a strong common voice when it comes to the battery industry in Europe. And it's my pleasure to say that, with companies such as Eramet, Eversync, Albemarle, Mate, Umicore, Solvay, or BASF, we really have some of the most renowned companies in the raw material production, extraction, and manufacturing sector among our members. And I'm very much looking forward to Minviro and Robert Bell into his presentation. So hi Robert. Good. So I was asked to elaborate on the lithium battery value chain and the development of the lithium-based battery value chain in Europe today. So I will be truly focusing on lithium batteries today. But let me start maybe with this. Advanced rechargeable batteries really are a strategic imperative for the social and industrial revolution towards a more empowered and sustainable society, right? And we do indeed live in an increasingly electrified world. So the battery technologies that Recharge represents, and these are many, being zinc, sodium, nickel-based battery technologies, but obviously also lithium-based technologies, they really serve a very broad spectrum of applications, products, from important grid services in a renewables-based electricity infrastructure, to e-mobility, to ITC, power tools, robots, but also then through to safety and backup installations. And lithium-based batteries really do play a very important role in that field of applications, right? Now, to give you maybe a little bit a better understanding, feeling for the magnitude of the role of lithium-based batteries, 3 key figures, right? The global battery market is divided into rechargeable batteries and primary batteries, so non-rechargeable batteries. And rechargeable batteries make up about 80%. And from this 80% market, right, we see that lead acid batteries, for example, do represent the majority, so more than 70%. Lithium-based only if I can say that, make up for about 27%. And you can see some others like nickel metal hydrate or nickel cadmium and others. So we do see that the market share as such gives one picture, but when we look at the market growth, right? So where does the growth of the battery industry comes from? We do see the leading role of lithium-based batteries with more than 90%. The group of others here includes batteries such as zinc-based, sodium-based flow batteries, for example, nickel-based batteries, right? I think this really gives us a very good picture of, how massive the innovation and the investment potential, the development potential is for advanced rechargeable batteries in Europe, but also globally. Now, how or what does this mean concretely for the European battery value chain, right? And maybe let me allow to go back a little bit in history, back to 2017, when the European Commission launched the European Battery Alliance. I think it is fair to say that the EBA gave a very important political signal to the battery industry, right, for battery technologies to further develop, for the European battery ecosystem to further develop. And the Commission recently provided a figure saying that the European investment volume reached some 60 billion in 2019. So a lot of that investment obviously goes into cell manufacturing, right? It is expected that within the next years, the annual production capacity in Europe for cell manufacturing will reach about more than 400 gigawatt hours per year, right? But also other parts of the value chain, they are ramping up their capacities. This includes mining projects, this includes recycling, so primary and secondary raw materials. And if we are looking now at the right side of the slide, we can see that lithium does play an important role in that investment dynamic, right? And this makes sense, I think. Lithium has been put this year on the CRM, so on the critical raw materials list. We also know from the Commission figures that by 2030, the lithium demand will rise by about 15 times what we have today, right? So I think it is just fair to say that a lot of focus also will be going into lithium supply. And I'm very curious to hear today how the geothermal lithium side is going to contribute to that development. Now, I think it is fair to say that the industry is ready. I think it is fair to say that research, the universities, you guys are ready to transform that tremendous investment dynamic, innovation dynamic into a new long-term status quo, right? But I also want to highlight that we do still rely on a sound legislative framework for batteries, right? Recharge is a very strong supporter of the European sustainability agenda, and we have been participating, we do still participate with scientific evidence and industry know-how in the various institutional work programs, with a great focus, obviously, these days on the revision of the Batteries Directive that is going to be published very soon on the 9th of December. Right, but in order to allow our industry to execute on these technological, environmental and social leadership ambitions as they were set out by the European Battery Alliance, I think it is very important that we highlight that we need 3 main pillars for the legislation. We need legislative frameworks to provide for a level playing field, right? We need to ensure that European batteries can be competitive, right? And not just on cost, but on other things such as sustainability. We also think that it is very important that we have measures that are being assessed on a value chain approach, right? On a life cycle basis, so that we can say that we really have a net value at the end, right? But what I think is actually most important is that we have lean and coherent legislation. We need to close the gaps in existing legislation, and we have to add those missing links that have been missing currently, right? And maybe it is worth to mention here, and I will be very brief, that batteries have been one of the products that have been first regulated on a life cycle basis, right? From chemicals management to product safety to transport and recycling. And there are some links that are missing. And to finish on this slide, the research vision for batteries includes that sustainable batteries are based on carbon footprint, so carbon intensity, that they are based on mandatory due diligence requirements, because these are the two missing links in the current legislative framework for batteries, and that we have a net value effective circular economy strategy that puts high impact material recycling at its core, but that is also capable of meeting the very differing, very developing sometimes waste volumes that we see today. And it is on this note that I would like to close my short presentation. I very, very much look forward to the following presentations and debate. Thank you.
Brilliant. Thank you very, very much, Pia. That was a fascinating overview. I'd like to move now to Dr. Horst Kreuter, who's the co-founder and executive director of Vulcan Energy Resources Limited, to give us an insight into geothermal lithium within the EU. Horst, we're about to make you a presenter, and you'll be able to share your screen and your slide deck with us. Perfect. Thank you very much. If you could switch your camera on as well, please. Perfect.
Yes, I do that. Yes, thank you very much for introducing me, and I'm happy to also be a part of this discussion on lithium today. If you see my screen, you see the label of zero carbon lithium. Zero carbon lithium is an initiative and a trademark that two geologists started about 2 years ago. My co-founder, Francis Vedin, and I founded the company, brought it to the stock exchange about 1 year ago, and now are on the way on developing our projects. And I would like to tell you a little bit about the geological background and how selective the lithium in geothermal is around the world, and show you what we are doing in the Upper Rhine Valley. So we are lucky that most of the lithium is stored in the upper continental crust. That is something we can make use of, but the way we are making use of at the moment is not very sustainable. You see there on the left are the large open pit mines in Australia, for example, that dig deep holes to get the spodumene, for example, out. Then from Australia, it is shipped to China, and the picture you see on the left bottom shows a picture that is representing the coal-fired power plant, the coal-fired heating that is used to cook the lithium out of the rock. So this is a very CO2 extensive process, and so the footprint of the lithium that comes from Australia via China has a very large CO2 footprint. On the other side, you see the salars that are in the driest desert of the world, on top of the Andes. And there, the salars are used to evaporate, to be pumped in basins and then to be evaporated to produce the lithium. Also, this is a CO2 extensive process because some of the reagents that are needed are shipped from the US and trucked up to the Andes to a level of about 4,000 meters. And then the product, lithium, is then trucked again down and be loaded on ships. So that they have not just a CO2 problem, but also a water problem, because it's a very dry area and they need a lot of water to do their process. So then looking at that, and my partner Francis was developing a open pit mine in Australia, and when he sold it to a bigger mine, he then thought about sourcing lithium from more sustainable resources. And so he looked at all the areas in the world where you have lithium in geothermal brines. And as you see a map of the world, you see that, for example, in New Zealand, they only have 14 milligrams per liter of lithium in the brine. In Japan, 2 milligrams per liter. Two main resources are sticking out. One of it is Salton Sea in California. You see they have content of lithium in the brine of about 180 milligrams per liter, which is quite similar or even the same as in the upper Rhine Valley that you see in the blue color in the center. There's also a brine that is used in Canada and developed by E3 Metals. This is a brine that is co-produced with oil, and they are planning to use these wells to also extract lithium. The lithium content is smaller than the ones of California and of Germany. There are certain parameters that define if a geothermal brine is useful to extract lithium from it. The first one for sure is the lithium content. The higher the better. But also there are other aspects that come into place. One is the flow rate. If you have a high lithium content, but you only produce 2 liters per second coming out of a well, then this is not economic. You need higher flow rates, and the flow rate, for example, that we are expecting and we have proven to have in the Upper Rhine Valley are between 50 and 100 liters per second coming out of one well. So the second decisive parameter is the flow rate. The third one is the quality of the brine. The brine have not just lithium in it, but also other elements, and how much of dissolved material is in the brine and what kind of material it is makes it more difficult or easier to extract the lithium. And in this respect, the Upper Rhine Valley, that's the area where we are active, sticks out because, for example, in Salton Sea, you have a lot more and more difficult elements in the brine that you have to look after if you extract lithium. So that's why at the end we selected to look at the Upper Rhine Valley for a lithium resource. Another parameter which is important is the situation where we are, because we want to avoid transport costs. And here you see a map with all the projects that are under development at the moment in Europe concerning lithium, and Mrs. Lange already pointed out that lithium is used and is expected in many of these factories around Europe. And with our mark in the middle, you see that we are right in the middle of the lithium demand in Europe, in the middle of the battery factories. The Kaiserslautern battery factory that is planned by PSA is just 80 kilometers away. The other one in France and Luxembourg, that has Saarland, that are planned are only a little bit above 100 kilometers away. So if we truck them with electric trucks or on barges down the Rhine River, we have all the opportunities to also reduce transport impact on CO2. The next slide shows you the situation of lithium production in Europe at the moment. There is no active mining or production of lithium at the moment in Europe, but there are projects planned. And you see that most of the projects, the ones in red, are open pit mines or deep mining projects. They are in Portugal, in Spain, in Cornwall, as well as on the German-Czech border. in Austria and in Serbia. All these projects are not of the size of the projects in Australia, but they also will contribute to the lithium, to cover the lithium demand of Europe. But they are not as sustainable as the ones with geothermal brines. And I put 2 blue dots for the geothermal brines in there. One is the Upper Rhine Valley, which is shared between France and Germany, and there are initiatives to make use of the Upper Rhine Valley in both countries. And the other one is Cornwall. Cornwall wants to extract lithium from mines as well as from brines. So there are 2 larger initiatives. Also, there's the North German Basin. The North German Basin has more than double of the lithium content than the Upper Rhine Valley. The problem, looking at the parameters that I just described of the North German Basin, is that they have a very low flow rate. So if you don't get a flow rate over, let's say, 30, 50, or 60 liters per second, economics are not that good. Therefore, the both blue ones are the ones that are the most interesting at the moment. The next picture, and now I come into our projects as an example of what can be done with geothermal brines. We are based in the Upper Rhine Valley, that is shown in the area between Frankfurt and Basel. And one very interesting criterion is the geothermal gradient, and the red colors show you the temperature, and you see that the Upper Rhine Valley is the hottest region geothermically in Central Europe. So that is also a parameter which is decisive, as I will show you later. The Upper Rhine Valley is a graben system. A graben system means you have faults that divide the graben into blocks, and the fault systems are the areas where the water flows, and the red granites that you find below, they are the source of the lithium. The water seeps in, for example, in the Black Forest on the eastern side of the graben. Then it by getting heated and picked up, by being heated and flowing through the deeper granites into the graben, they pick up the lithium that we then harvest in our reservoirs, like the Bunter sandstone in the fault zones that have a lot of permeability to produce a lot of water. The next slide shows you all the data that we have gathered and that authors and scientists have gathered about the lithium content in the Upper Rhine Valley. And from all these, we know that we have an average of about 180 milligrams per liter in the Upper Rhine Valley. To develop a resource like that, you need a license, which is based on the mining law. So you have the exclusive right to explore and to exploit lithium in an area that you have a license. Vulcan Energy is owning some of these licenses in the Upper Rhine Valley. So that is the basis of our economic development. The next slide shows the principle. What we are doing is we have a normal geothermal power plant, meaning we have production wells, we have an injection well. In between, you have the production of electricity, and also if you have customers, you can provide heat to the customers. And then what we add to it is just before re-injecting the brine, we take out the lithium in a so-called direct lithium extraction process. And after the lithium has been taken out, the brine is then re-injected. The special thing I want to point out here is that we are in parallel producing energy, electricity, and heat from the geothermal resource, and we also use this electricity and heat to a certain extent, about 50%, for the extraction process, and sell the rest of the heat and electricity to the grid. When we have produced the lithium chloride on site with the DLE process, we then ship the lithium chloride to a centralized refinery where we produce from the lithium chloride lithium hydroxide, which is the material that the people ask for if they want to produce batteries. Our project is divided in 3 parts. One is the geothermal power plant, drilling, and an ORC power plant to produce the electricity. This is a well-known process all over the world and also realized, for example, in several projects on the French and the German side in the Upper Rhine Valley. Attached to that is the direct lithium extraction plant, which is also a known process that we are using. We have just to adopt it to the geothermal brine of the Upper Rhine Graben, and we are doing that starting with laboratory experiments that we have already finalized. Next steps for us will be a pilot plant to prove how we extract the lithium from the brine. And then the next step is, as I have told you, the lithium refining plant that takes up the lithium chloride from several projects and refines it to hydroxide. To cross over to the next presentation, I would like to show you an example of a comparison of geothermal brine from other production of lithium that was done by Minviro, and it shows that you have the hard rock projects producing lithium, and they have a very high CO2 footprint of 13 to 15 tons per ton of lithium hydroxide. If you look at the salars in South America, it's lower, it's about 5 tons. And if you look at the geothermal projects producing lithium, you can say, if you want to see it that way, that we are even CO2 footprint negative, because we are not just producing lithium, but also we feed in our electricity and our heat in the grids, and therefore replace CO2 intensive coal, for example, or gas-fired power plants. So if you want to see it this way, we're carbon negative, and that's a big difference to the other production scenarios of lithium in the world. Thank you very much.
Thank you, Horst. That was a fascinating insight. There's already questions which have come in for you, but if you don't mind, we'll do them during the Q&A session towards the end. Now it's my pleasure to introduce Dr. Robert Powell, who's the founder and director of Minviro Limited. Robert, if you could turn on your camera, you should have access to your screen shortly.
Great.
Yes. Hi, Robert. Excellent. Thank you. Over to you.
Thanks very much. Can everybody see that now and hear me? Perfect. Great. So that was a great sort of lead in to this presentation. So Minviro, I'll give you an introduction to Minviro first. So Minviro is a consultancy and technology company based in London, UK. We provide life cycle assessment consultancy and technology solutions. And today I'm going to talk about that study that was just highlighted there, which was the first public life cycle assessment of lithium hydroxide production from various sources. Great. So let me just. So I'll introduce you to how we get these values. So we use an approach called life cycle assessment, which Alina spoke about earlier, which is a very important way of quantifying the impact of batteries, but it can also be used for the production of lithium from geothermal or other sources. So life cycle assessment, it has its ISO standards, and within that ISO standards, it has its definition of what life cycle assessments do. So it allows a quantitative assessment of the environmental performance of a product or process over its entire life cycle. So it's been around for a few decades, and it's been widely applied in other sectors, but it's only really recently sort of risen to popularity in the raw material sector, and that's really important, especially for the battery revolution. We need to know the impact of these raw materials that are feeding it. So you can see on the left, there's a standard approach to carrying out a life cycle assessment. You have the goal and scope phase, which is when you're identifying, your system boundary. So what you're including in your study, what your functional unit is, that's what you're measuring the impact against. So we saw some CO2 impacts, but that was in reference to 1 kilogram or 1 ton of lithium hydroxide. So that would be described as the functional unit. You then have the life cycle inventory. Now, this is the really important and challenging phase of life cycle assessment. This is where you collate and collect all the data for the material and energy inputs for your system, and also calculate the direct emissions to either air, water, or land. And then you will then carry out your life cycle impact assessment. So that's how you get your values such as climate change, but a whole range of other impact categories, which I'll show shortly. And throughout this process, you're interpreting the results from each stage and making sure that you are adhering to the goal and scope that you defined, or making any amendments if necessary. So the graphic on the right just gives you a very sort of high level view of what this might look like. So if you imagine you've got the dotted line, which is highlighting the system boundary. So we're trying to measure the impact of everything within inside that boundary. But you have to imagine that we have the input of raw materials and energy, and obviously those emissions. And then we have that reference products that I talked about, which is the functional unit. But often for these processes, we have co-products. And for the example with geothermal lithium, we have a co-product of energy. So we always have to allocate impacts according to these co-products. And this is a really interesting area within life cycle assessment, and there's different methodologies under different scenarios. So I mentioned climate change. Climate change is rightly at the front and center in the public eye. But we also have to remember that the production of these raw materials can have impacts on a range of other impact categories. The principle of life cycle assessment is that you're not designing a project, or you're not quantifying impacts just to minimize one single impact category. You want to make decisions informed on the range of impact categories. So if you're saying reducing the climate change impact, let's make sure that we're not significantly increasing particulate matter somewhere else in that supply chain or system. And so this little table with these arrows just highlights what impact categories might be particularly relevant for lithium production or geothermal lithium production. And you can also see a level of priority and a level of confidence. This information basically says, how important are these impact categories within this for the environment, and what's our level of confidence, what's our scientific robustness for this calculation methodology. So I'm going to talk a little bit in more detail about that life cycle assessment that was mentioned previously. So we carried out a life cycle assessment comparing the production of lithium hydroxide sourced from brines in the lithium triangle. So one location being in Chile, one location in Argentina, and then compared this with spodumene, so hard rock deposit in Australia, and then being converted in China. And then we compared this against earlier stage but geothermal lithium projects. So we basically wanted to do a comparison of what the environmental impacts of these different production routes. And so you can see the process described here for these different routes and the inputs for these different scenarios, including the transportation stages, both of the reagents to the sites, but also transportation between the process stages. And one thing to take into account early on is the impact that you'll see for the project from Chile is technical grade lithium hydroxide, and the rest are battery quality grade. So that's something that's not quite the same functional unit, and so we just need to take that into consideration when we're looking at the results. So these are the results. This is the graphic, which is similar to the one on the previous slide, but just highlighting a few other projects. So you can see on the right, the blacked out the data is highlighting the CO2 intensity of producing 1 ton of lithium hydroxide monohydrate. And you can see that the impacts range quite significantly. And I suppose the thing that I want to get across here is there's not one impact for lithium hydroxide or any lithium chemical or geothermal energy per kilowatt hour. It really is important to carry out life cycle assessment for specific routes, because I'm a geologist as a background, and so from a geologist perspective, I know that there's different processing routes and different energy requirements and chemical requirements to get that material out of the ground and get it into a refined final product. And the life cycle assessment approach is really good at really highlighting those different impacts. So you can see on the left that the CO2 intensity of geothermal brine, this was Vulcan's project, had a negative carbon footprint, and this was achieved because of its low CO2 intensity for production, but also because of that offset of geothermal to the grid. And we can talk a little bit about, we did another study, another white paper, looking at the sites around the world for the potential combination of geothermal and lithium, and which sites might look particularly attractive. So this is just reinforcing what I was saying, that there's not a single impact score for lithium hydroxide. There's not a single impact score for any of the battery materials, and there's not a single impact score for geothermal. They all have their own impact depending on the processes and the technologies that they're using. So this is some work that a colleague of mine at Minviro did, so Alex Grant. This was a little bit of I suppose, a thought experiment looking at, although brines in salars, so in South America, have the advantage of utilizing very, very cheap energy, they actually are more energy intensive in that process stage. So that this won't, although this graph is a little bit complex, so it highlights the different concentrations and the land footprint and also the energy intensity. So basically, the process of using direct lithium extraction from geothermal lithium brines is it's more precise use of energy compared to using solar energy for evaporation. And this was just an interesting way to look at the problem. So, would it be more efficient to use direct lithium extraction in the brines in South America? That's obviously something that might be challenging economically, but it's an interesting point. But also highlighting that the land footprint, as mentioned in the previous talk, that the land footprint is quite a lot larger for those salars in South America as well. And so this is looking at some opportunities so not looking at the lithium reserves, but just looking at the potential to offset grids in different regions. So this is looking at in the life cycle assessment data, what is the current average grid intensity for a particular region? And what is the average geothermal electricity CO2 intensity for that region? Now you can see that there's quite a big range here, and that's again to do with the geology. So you can see that in certain regions in Turkey, you have geothermal energy, which has a very high CO2 intensity. And that's because of the host rock, carbonaceous host rock that it exists in. And in terms of a LCA perspective, it wouldn't make much sense. You wouldn't get an offset for providing geothermal energy to the grid in that region. However, there are certain locations like Germany and the UK where you can make quite significant impact reductions if you're feeding electricity into the grid. And if you can combine this with lithium production, it's quite an attractive concept from an LCA perspective. And just a brief highlight, just to give recognition to those who contributed on this life cycle assessment study. Yes, so Alex Grant and David Deek are our lithium experts based in the US, and really helped us in understanding the life cycle assessment for this lithium hydroxide route. And so that's all I've got at the moment. But I also have, we've also covered other impact categories. So in the discussion afterwards, I'd be happy to hear any questions about the methodology that we applied for this life cycle assessment and how the performance in other impact categories compares. Thanks.
That's brilliant. Thank you very, very much, Robert. There's a few questions which have come in to you as well, but again, we'll take them in the Q&A session at the end. Now I'd like to introduce Mr. James Firth, who's the head of energy storage at Bloomberg New Energy Finance. James, if you're able to turn on your camera, and you should be made the presenter now.
Yeah, perfect. I am just opening this up. Hopefully you can hear me.
Yeah, loud and clear.
Let me turn my camera on.
It's okay.
Yeah. Sorry, I'm just going to have to.
Don't worry. Perfect.
Hopefully you can see and hear me now. And
yes.
Let me now just share my PowerPoint.
It's perfect.
Okay. Okay, perfect. Sorry about that.
That's okay. That's okay.
Great.
We can see you. We just can't see a slide deck at the moment.
Okay, let's see if we can switch to this then. How about now? Is that any better?
I can't see it. Maybe Valeria, if you're still on the line, maybe you can help us out. I think. Oh, there you go. Yes, perfect. You have to change settings so that it's just the main screen. We can see.
Let me just. There we go.
Perfect.
All right. Sorry about that.
That's okay.
Perfect. And let me just. So yes, that's great to be here today. Today I'm going to be talking about kind of Europe's position in the battery supply chain, and hopefully kind of bring together, I guess, kind of why there is a need for sustainable production of lithium in Europe and other materials. So I'll kick off now, as I realise I've held us up a little bit here. But this is a look at EV sales globally over the last 5 years or so. And I think this chart is really interesting because it shows something that I think a lot of people would be surprised by. I was certainly surprised myself when I saw this. But in 2020, as it stands at the moment, Europe will be leading the world or kind of neck and neck with China for passenger electric vehicle sales. And that's something that even last year seemed kind of almost impossible. And that was despite the fact that we knew that we had these kind of looming fleet-wide CO2 emissions coming into play in 2020. The actual reaction to those fleet-wide CO2 emissions has been far better than I think we at Bloomberg NEF expected. And that's also combined with a slight downtick in new passenger EV sales in China because of, one, the global pandemic, and two, because of some changes to the NEV subsidy scheme that we've had over there. But as I mentioned, yeah, this is really quite astounding to see that Europe has kind of taken or is catching up with China for that number 2 or number 1 spot. And what's great to say is that it's not just confined to 2020. This isn't a one-off. At Bloomberg NEF, based on the modeling that we do around electric vehicle adoption, we expect that Europe will continue to kind of hold that number 2 position well into the 2030s and out until 2040, and that there'll be more passenger electric vehicle sales in Europe than there are in the US and many other parts of the world. So electric vehicle demand in Europe is kind of growing massively, and with it, we need to have the batteries that go into those electric vehicles. As it stands today, despite the fact that we're kind of neck and neck with China for new electric vehicle sales, actually only about 6% of commissioned lithium-ion battery manufacturing capacity is in Europe today. But I'm glad to say that is changing. And by 2025, we expect that around 17%, so almost a fifth of commissioned lithium-ion battery manufacturing capacity will be in Europe. And that doesn't include some of the kind of new announcements that are out there where capacity hasn't necessarily been announced. And so one example of that, for example, would be Tesla's gigafactory in Berlin, where we know they're going to manufacture cells there, but we don't know exactly how many yet. But announcements like that will increase Europe's lithium-ion battery manufacturing share as well by the time that we get to 2025. So we have the electric vehicle demand, and we have the kind of growth of the cell manufacturing industry to help meet that demand. So clearly, you know, we're taking steps in the right direction in Europe to kind of help secure that that lithium-ion battery supply chain. But at the moment, it tends to kind of stop when we get to the cells. If we go further up the value chain to look at the components, you can see that the majority of those kind of crucial components going into these batteries, the anode, the cathode, the electrolytes and separators, they still tend to be manufactured in China or Korea. And so there's clearly some work that needs to happen in Europe to kind of attract more of that upstream value chain. But I'm also kind of pleased to say that we do see that coming as well. So we've seen, for example, BASF has a joint venture with Nornickel in Finland to manufacture cathodes. Johnson Matthey is looking at where in Europe to manufacture its cathode material. Certainly Poland has initially been chosen. It may look to other areas as well. And then Umicore as well is building a manufacturing base here. But again, that's kind of very much limited to the cathode. For the other components, we do start to see some activity there, but it's still slightly further behind. But that's also to be expected. When we see a new cell manufacturing facility being established in a region, particularly if the owners of that facility are headquartered in say, Korea or China, actually, when they first commission their new cell facility, they'll use their existing suppliers from their home market, so from Korea or from China, and they'll ship that material over to Europe until that new cell manufacturing plant can produce cells of as higher quality as the cells that could be produced at its home plants. And once they can produce those cells at that high quality, then we'll start to see them looking for more local suppliers. So actually, it makes sense that as it stands today, the majority of this kind of component capacity is in Asia. But as we get to 2025 and we see more kind of local facilities being commissioned in Europe, we expect that part of the supply chain will also start to be localized within Europe. But what happens if we go even further up the value chain? Well, if we look at the kind of key raw materials, at the moment, kind of for cobalt and nickel, Europe doesn't have a huge amount of kind of skin in the game, if you like. We don't have much direct access to these materials. I'm glad to say, you know, as we've heard today, that for lithium, that's certainly beginning to change. There's a huge number of projects that are being developed in Europe that will help us kind of get access to those materials. But on top of that, the new funds that are being created by the European Investment Bank, the European Commission, EIB, etc., also InnoEnergy, etc., you know, they will also help to increase Europe's access to these key raw materials. And so going forward, although this takes kind of, again, you know, longer to develop these raw material projects, as we get towards that kind of 2030 mark, not only do we expect that we'll have more electric vehicle demand in Europe, we'll have more cell manufacturing, more component manufacturing, and actually we'll have direct access to a lot of those key raw materials. And it's worth bearing in mind as well that the kind of raw material space is changing as the chemistries change. So we've seen over the last decade, for example, a move away from kind of high cobalt chemistries to higher nickel chemistries. So we've moved from one of the kind of popular chemistries at the beginning of the last decade was a chemistry called NMC 111, which had equal parts nickel, manganese, and cobalt. Now one of the kind of more popular chemistries is NMC 622, which has more nickel, less cobalt, and less manganese. But actually going forward, by the time that we get to kind of 2025 and then beyond that to 2030, we expect that we'll start to see growth in higher manganese chemistries. So less nickel, more manganese. And some of those will also have a slightly higher lithium content as well, so they'll be over-lithiated. And actually, that's kind of great news for Europe because we do have kind of manganese resources available to us. We still need to tap into them and get them. But similar to building out lithium projects, building out manganese projects is also something that we can do in Europe and to help increase our supply over the raw material value chain. So why should we kind of be thinking about this now, other than trying to be self-sufficient? Well, it's also worth remembering that the battery market is growing dramatically, and we want to be able to corner some of that market in Europe. We don't want to have to rely on other countries for that. And so between now, where the lithium-ion battery market is worth roughly a quarter of $25 billion annually, by 2030 it'll be over $100 billion annually. And so by acting now, we can make sure that Europe is established in that supply chain and has access to those key raw materials. Now, it's worth pointing out that actually lithium-ion battery demand is growing at a faster pace than the annual size of the market. And the reason that the annual size of the market isn't growing as fast as the kind of gigawatt-hour demand is because battery pack prices are falling. Over the last 10 years, we've seen battery pack prices fall from over $1,000 per kilowatt hour in 2010 to around $156 per kilowatt hour in 2019. And at Bloomberg NEF, we're in the process of carrying out our 2020 survey at the moment. And our current expectation is that in 2020, lithium-ion battery pack prices will be at about $130 per kilowatt hour. And what I think is really interesting about this, a couple of months ago, I was looking at some of the first work that Bloomberg NEF did on battery pricing back in 2011. And in that work, we forecast that by 2020, battery pack prices would be at about $350 per kilowatt hour. So you can see that we managed to smash through that target about 5 years early. Now, the second number in that report was $140 per kilowatt hour. And that was the pack price that Bloomberg NEF was forecasting for battery packs in 2030. So it looks like we'll be set to smash through that barrier about 10 years early. So it's great to see the kind of rapid pace of battery cost declines that we're seeing. And these cost declines have been in part because of the growth in the market that we've seen. And, as we've seen, I think most people will be aware, lithium-ion batteries were first used in consumer electronics. Eventually, they became developed enough and cheap enough to be used in passenger EVs. And then slowly, as they've come down in price, we've seen more sectors electrifying, which kind of helps to increase the battery market and help drive economies of scale. But it's not just the growth in the sector. We've also seen, as I mentioned earlier, a chemistry change as well. So we've gone from these chemistries in the beginning half of the decade that had quite high material costs. So they required quite a high number of kilograms of material, but also had expensive material in them. So a lot of cobalt, like I mentioned earlier. And we're moving towards these new higher energy density material that have less of the expensive components within them. So I skipped a slide there. So you can see, for example, going from that NMC 111, because it had a low energy density, you needed more kilograms of material than that NMC 622 that's popular today, but it also had more cobalt, which is expensive compared to that NMC 622. So these kind of changes that we've seen have really helped to drive down prices. if we look to what's coming, if we forecast out battery prices based on the kind of data that we've collected over the past 10 years, what we find is that by around 2024, lithium-ion battery pack prices are below $100 per kilowatt hour. And that's important because it's around that point when you start to reach price parity between internal combustion engine vehicles and electric vehicles. Of course, it depends on the region that you're looking in and the vehicle segment that you're looking in, but it's around that $100 mark where you start to get mass market price parity. If we forecast out those prices further, by 2030, what we find is that the kind of volume weighted average of lithium-ion battery packs will be around $60 per kilowatt hour. So it seems kind of extraordinary from where we are today to realize, to kind of understand how much cheaper battery pack prices could get. But actually, I think it's reasonable to expect that we will get there. And actually, if we look back, as I said, the kind of rate of cost declines that we've seen over the last decade, prices have fallen much faster than we initially expected. That being said, getting to that kind of $100 per kilowatt hour mark is something that we think is very achievable. We think there's a clear path to do that with the current generation of technology, with the liquid-based lithium-ion system. Getting to that $60 per kilowatt hour mark is much harder. And not much harder than we don't think you'll be able to use it, but it's much harder to say what route will be taken because there's so many different technologies out there and available, things like solid-state batteries, silicon anodes, and a whole host of new next-generation cathode materials. And although there's a number of different paths and it's hard to say exactly how we get there, I think one thing that's worth highlighting is that for a lot of these kind of next-generation technologies, actually they'll open up the need for new supply chains. Solid-state batteries, for example, will use solid electrolytes that use a host of materials that aren't used today in lithium-ion batteries. Similarly, that may open up the way to using lithium metal-based anodes. And again, the supply chain for that isn't yet established. So there's an opportunity for the European battery industry to really think about what the future holds and try and get ahead of that now and start developing those supply chains. I'll leave it there for the moment, and yeah, hopefully there are some questions that have come up, but I look forward to answering them in the Q&A later.
Brilliant, thank you so much, James. This is if I was to summarize what we've just heard so far, we've heard a lot about the geology, we've heard a lot about the chemistry, we've also heard that this is by 2030 potentially $116 billion market. So it's over to one of the leading regulators in the European Parliament, Ms. Claudia Gamon, for the Renew Group, to maybe give us some insights into how we can actually realise the value in the industrial power base that's presented. So over to you, Claudia.
Thank you very much. Those were some very, very interesting presentations. I want to thank you for the invitation to this webinar. It's a great pleasure to speak here. My name is Claudia Gamon. I'm an MEP from Austria in the Liberal Renew Europe group, and I serve on the Committee on Industry, Research and Energy. And this year I was the rapporteur for an initiative report on energy storage that was passed in July of this year. We've heard a lot about lithium extraction and the lithium-ion battery industry as a whole, and I would like to focus more on the regulatory framework. Well, of course, keeping in mind that we in the Parliament, and I especially in my group also, really want to focus on what it means to realize a technology neutral approach. But I do believe that this is a great example of what this would mean, because we want to regulate also for technologies that also might not yet be fully market ready, or that we don't yet know about, but have huge potential. And I do believe that a regulatory framework has to work for those as well, so that the market in the end can also have a say in which technology will prevail. I would like to start this by focusing, well, what is the starting point for drawing up regulation? And that is obviously our commitment to become the first carbon neutral continent. This will have various consequences, and one of them is a higher share of renewable energy sources, but also increased energy demand, because the decarbonization will mainly be driven by electrification in the biggest sectors and lead to a significant rise in energy demand. There are many calculations right now, but I think most of them agree that the electricity demand will double by 2050. So that is quite hard to imagine in the current situation where this all might come from, but it will have to come from renewable energy sources. And this obviously presents us with new challenges, and one of the most important one that we have to face is higher volatility in the electricity grid. And in order to tackle this, we will need increased storage capacities. And this storage will have to be sustainable in some way, and will have to be those will have to be sustainable technologies. And this is what this initiative report, where I was a rapporteur for, mainly talked about. We looked into what are the general regulatory barriers, but also for concrete technologies such as batteries, with keeping in mind what do we need to find and to give sustainable storage solutions a way to succeed in the market. And I want to go through the 4 most important general barriers that we identified for this report, and give you some examples of what we talked about. For example, one of the topics that we saw was how can we deal with the problems that lie with the dynamic between having a need to secure the energy supply on one hand, but also local resistance to infrastructure projects on the other hand. I think Switzerland is a great example on how to involve all stakeholders in larger infrastructure projects from the beginning on, in order to really give everybody a perspective. Why do we need this? How is this good for you? And if you have any problems, how can we solve them? So there's lots of talk needed. And I believe that we also will have some topics to talk about when it comes to batteries, for example, because there are some fears with citizens about safety of them. So communication is key. Proactive communication is key. Another topic that we identified was double taxation and network charges as one of the huge barriers that we have to talk about, because this is obviously a problem for market access. So I think that double taxation should be abolished in the revision of the Energy Taxation Directive, and we have to rethink network charges. This is not about abolishing them, but finding a new model that works for new technologies, which is the system has changed, and I think we need to work with that. Another topic, the third topic, is the lack of clarity in state aid guidelines for storage projects in general. Currently, there are only few state aid measures in general that have passed for storage projects, and we identified the problem as to that there needs to be a clear reference to storage projects in the revision of the state aid guidelines, in order to have a clear saying that this is important. We also want you to invest in this, in these technologies. And the final point of the overall general barriers that we identified was the lack of commercialized usage for research findings from Horizon 2020 projects, for example. We believe that there should be more closer to market research in this area. I think, and I want to keep this rather short because I know we're already short on time, and I think it's important to also answer some of the questions that have been posed. I believe that batteries will play a key role in the transformation to renewable energy sources, to serve short-term uses to balance the grid, but also to provide larger storage capacities from households up to an industrial scale. I believe for many people in the general public, it will be hard to imagine how this will work, but I believe it's important to continue research to make these technologies succeed in the market. I really do believe in battery technology, but there are many things that we have to keep in mind in order for it to stay sustainable and to find new, more sustainable alternatives. Lithium-ion batteries are state-of-the-art, and they have seen a significant reduction in cost in the past years, obviously driven by the heavy investments from the automotive sector, which we profit from in other regards, obviously, as well. However, what is important also from a politically strategic perspective is the challenges such as the stronger dependency that we have on manufacturing in third countries. That is obviously also not just a sustainability problem, it's a political problem for the European Union. Also, there are no proper recycling schemes in the EU. There are no safety standards when batteries are repurposed for different uses. When a consumer wants to use his car battery as a storage unit, for example. Those are things that we have to talk about right now, find regulatory solutions right now, because the market potential is huge. But in order for this, for many new companies that are starting up to succeed in the market, they need to be sure about the regulatory framework that is set up for them. So I do think that the goal should be to really build this regulatory framework also for batteries in this legislature, absolutely. So, and there is something coming up, hopefully very soon. We are eagerly awaiting the review of the Batteries Directive, and there are a couple of points that I believe will have to be addressed. First of all, the sustainability issue. So we need to be able to compare the CO2 footprint not only of batteries but of all storage technologies to have to be able to make the comparison. Transparency is key here. I think, especially seeing that the necessity of storage will increase with the share of renewables, we need to make sure that we're not fostering technologies with a high carbon footprint, especially in their afterlife. So I believe there's one that we have to find European standards for battery production as well, and I truly believe in this point. And to focus on recycling as well, I think it's important to introduce recycling targets as well for lithium-ion batteries and other emerging batteries technologies to really make use of these very, very valuable raw materials and reduce the dependency on third countries. And also there's a blueprint, obviously, when you look at lead acid batteries in the automotive sector. So I don't think we have to reinvent the wheel there. And there have to be guidelines for second use of these battery types. In order to I believe that trying to refer to the topic of today, that geothermal lithium can contribute substantially to reduce our import dependency on third countries, and at the same time also reduce our carbon footprint relative to the traditional extraction process, and by that also supporting our Green Deal objectives. And I think that those kinds of innovative approaches are very important. We have to find a framework that works for all the innovation that is also yet to happen and that we have yet to find, and that I believe is the goal that we have to set for ourselves in regulating in the battery industry. So to sum things up, to continue to the questions, we have two main assignments, I believe, to complete in order to meet these ambitious goals by 2050. First of all, removing regulatory batteries to allow for a broader range of storage technologies to evolve and to meet the future demand that is coming, even if we don't see it just yet, it will be there. And to foster technologies that are clearly tied to the high environmental standards that we do not only want to have in the European Union, but also want to export to the rest of the world. And I believe that batteries will play a key role here. And I do think that it's great to have these innovative approaches for a more sustainable way to do that. Thank you.
Thank you very much, Ms. Gammon, for that fantastic overview. And actually, it's provided a lot more clarity to our conversation. Let's see if you can bring my camera up again. I have forgotten what I'm doing here, but you should be able to see me there. Okay. We've got about 20 questions, and I've got some questions coming in via SMS from former colleagues in the European Parliament. So we're not going to be able to go through all of them. What we will do is those which I will ask all of our speakers at least one question, if they could keep their responses very, very brief. And then the questions that we're not able to raise, I'll ask the speakers to draft a response, and then we can send that on to everybody who's posed their questions. So that way everything is covered. Okay, so let me just okay, I've no idea what I'm doing on my screen. Okay, here we go. Evola. Okay, so in terms of questions, I'm not sure how we're going to do this. I'm going to stop sharing my screen. I'm going to ask my colleague Valeria to put the agenda up so I can actually go through people's questions, and they have their right to anonymity, as one or two people have asked for on the call. Oh, sorry, on the question side. If I could go, maybe start off with Horst. We have a question from actually one of our excuse me, one of our members, Ms. Beata Kwiatkowski, our member from the Polish Geological Survey. She asks, oh, wait a minute, what's happened? Voila. What have I just done? Okay, she asked a question, but I think I've accidentally deleted it. I'm so sorry. Okay, we will go to the first question, which came in from the University of Geneva, a colleague there. One, can cogeneration, power heat and lithium be a solution to improve the economic viability of geothermal projects? And the follow-up question to that is how long could a geothermal well produce lithium? Yes, those two questions. If I could keep our responses short, please.
Yes, the last one was the one about how long can we produce lithium. We are tapping into fault zones that are reaching deep into the Earth crust. So when we inject the water that has been depleted of lithium, it's heavier because it has been cooled. So it's traveling down again into the deeper zones, into the granite. And by heating up is picking up lithium, dissolving it from the micas in the granite. So there will be some contribution to that. There have been done laboratory experiments that show that the leaching of lithium from the micas is temperature dependent. So the higher the temperature, the more lithium is leached out. So, and we have seen in Sous-Forêt that, you know, if you pump down water that is clear without lithium and it's circulating through the fault systems in the granite, then you have lithium in it. So we think there's some recharge, and also when we produce, not 100% of the produced water is coming from re-injection well. We attract water from below, we're attracting water from the sides. So there might be a decline. It might not start right from the beginning, and it will be slow because of the recharge. That is our assessment at the moment. But you know, we don't have the experience in the field yet. And the other question was about, you know, can lithium contribute to the financials of a geothermal project? Yes, indeed, because we think that we have a very high feed-in tariff in Germany of 25 euro cents per kilowatt hour. So that is the basis of the financials of geothermal power production. But we have assessed that the financials for the input of lithium into the financial is 3 times as high as the one from selling electricity. So it really is contributing.
Okay, brilliant. Thank you very much. To Claudia Gammon, we have a question. I'll read it out. Does your call for frameworks for innovation in producing battery materials yet to be developed include allowing fossil fuel production to harvest the associated chemicals in those fossil fuels and in the waste brines which come from production? I'm not sure if you understand that or read that one properly.
No, actually we didn't cover that in the report. I also don't think that it would be covered in the batteries directive. I don't think so. However, well, this is something that should be included when talking about calculating the CO2 footprint along the value chain of any technology. I'm rather pragmatic here. I believe that we will have to find calculations to really have a transparent view in the end. What is the sum? What is there? It will be hard to find a technology that along the entire value chain is completely carbon neutral in that way. But we will have to be honest in comparing them. So it shouldn't only be about the imagined carbon footprint, but the actual one. And also in terms of batteries, trying to include the potential for second life. So I just think there should be a transparent process, and I believe that it's also the job of the Commission to provide us with this information.
Excellent, thank you very much. To Pia, I have a question which came in via WhatsApp. Is the current rules and regulations and the regulatory framework on battery recycling adequate, and what more needs to be done from the Parliament? I imagine this is the Commission, EU regulators, to ensure that we have sustainable batteries in Europe. It's a long question.
I didn't get the last part of the question, but I did get the first part of the question regarding recycling. So let me start with a very general comment or statement, which I think is very important. All battery technologies are suitable for recycling, right? About 95% of the metals used in batteries are recycled today, and this includes actually for lithium-based batteries. I think this is very important that we state it. Now, when it comes to improving recycling efficiencies, yes, this is very important because recycling is indeed one of the most effective ways to improve our resource efficiency in the industry, right? But I think it is also very important to have a competitive and innovative recycling infrastructure here in Europe. And we have to bring together two facts, right? I'm an economist, so I will speak about the economic side to it, right? We have to bring together innovation and industrialization with waste quantities. Because what I think many people don't understand, recycling is a highly waste-driven or volume-driven industry, right? If we don't have the waste volumes, it is very energy intensive, right, per unit, very economically rich to recycle small quantities that do not really bring a significant impact to the circularity of resources, right? So we have to bring together these 2 points, and I'm very much looking forward, obviously, to the 9th of December, when we are going to see more on the recycling side across the battery technology spectrum, and yeah, so.
Brilliant, thank you very much. To you, James, the question I've had here is, you talked a lot about the declining cost of batteries. Are we close to seeing a mature market for lithium-ion batteries, and do we need to have more policy-orientated measures? Okay, let's assume, do we need more EU policy to drive this market forward, or is it going to grow on its own? We can't hear you, sorry. We can't hear you. No.
Essentially, maybe while James is trying to.
Sorry,
okay.
I needed somebody to unmute me there. I had no control. But yeah, essentially, I think the battery industry, it's a difficult one. It is mature today. Clearly we have established supply chains, particularly in Asia, and we have very well understood manufacturing processes. That being said, actually, I think we're generally looking at technology that has been around and developed for the last 30 years since Sony first commercialized the lithium-ion battery back in 1991. We've just been kind of slowly improving on that same technology. I think probably what we're about to find, particularly in the manufacturing side of stuff, is that there's going to be a large number of changes that are brought in that actually change that manufacturing landscape. And we can see that happening in Europe already. Freya in Norway recently licensed a technology from a US company called 24M. And that technology in itself and manufacturing process is significantly different from what we have today. So I think that the industry and technology is mature, but that doesn't mean that it can't change and we can't have kind of more innovative approaches now being introduced.
Okay, thank you very much. And then finally to Robert, I'm conscious that we're coming up to the 12:30 cutoff point. When you looked at your life cycle analysis, the methodology that was based, is this something that can be used? Is this primarily something for European audiences, or could this be the basis for an international regulation to basically move the entire global footprint?
No, I think absolutely it could be international. I mean, there's efforts with the Global Battery Alliance and battery passports. I know that there's intentions there to look at it on an international level. Our life cycle assessments aren't Eurocentric or anything. We cover materials all around the world, and the reality is the materials, even if materials might be sourced from Europe, they still have the chance of going out of Europe for processing and then come back in. And so you really do have to take an international look at this and understanding, life cycle assessments not just for measuring impact, it's also for mitigating during these development stages. And this is the optimum time now, as we have this explosion of raw materials for the battery revolution, to be applying life cycle assessment for these projects. So we design these projects with environmental considerations.
Brilliant, thank you very much. Well, we're coming up to the 12:30 cutoff period, so I'd like to take this opportunity on behalf of my colleagues within EdGec and the geothermal community to thank you for a fantastic conversation. We've learned many things. If I was to summarize them, this is a big market. We need to have good sustainability standards, but we need to make sure that we have the right policies and regulations to ensure that we capture and realise this industrial strategy within the EU. And front and centre to all of this is geothermal lithium, but also the many other benefits of geothermal energy as well, which we'll be discussing in future events. So thank you very much for giving us these fantastic insights, and thank you to everybody who logged in and remained on the webinar for so long. We look forward to seeing you all very soon. Bye-bye. Bye-bye.
Bye.
Bye-bye.
Thanks.
Bye.
Bye-bye. Complete.